All right, today's lesson, Unit 4, Lesson 6, Solving Polynomial Equations, the shortest version ever. Okay, so we're going to try to collapse this into the most efficient way possible to get you to where you might possibly need to go in the realm of solving polynomial equations without getting too tangled up in all the different things that might happen with polynomial equations. In the previous lesson, I said that when it comes to graphing polynomials, there's just lots of stuff in there. And the same is true with solving polynomial equations. And we could spend weeks and weeks and weeks on this concept and then still not make a whole lot of headway. So what we're trying to do this year anyway is get you where you need to go with a solid foundation as quickly as possible, and not showing you shortcuts, not showing you like little ways to get around understanding the material, but just homing in on the important ideas and pieces in that material, combined with an efficient way to use that knowledge to hopefully get you what you need in order to move on to your next step mathematically. So what are we looking for? This I can't review enough. This is so important because it's one of those key foundational ideas that never changes. And if you can get out of like, give me a shortcut mode, and get to like, how do I understand this? What are the things I need to understand? This is one of the foundational ones. What is a solution? If you are being asked to solve an equation, what are you trying to do with that equation? A solution makes the equation true all the time. Okay, all the time. That is what any solution to any equation, whether it's a simple equation or whether it's a crazy complex equation, nothing you've ever seen before, okay? You're still looking for the same thing. You're looking for the value of that variable or variables, if we're talking about a system, that's going to make that equation true when you plug it back in. Okay, now the more complex the kind of equation, then the more complex the strategies are and the more tools we need to plug in. But what we're looking for never ever changes. The number of solutions a polynomial equation has is equal to the number of roots. Okay, and so this is where we tap into the previous lesson. How many solutions you're looking for is equal to the number of roots that you have. In other words, it's equal to the degree or that highest exponent. So if the highest exponent is 1, you've got 1 solution. If the highest exponent is 2, you have 2 solutions. If the highest exponent is 7, good luck with that. You've got 7 solutions that you're looking for. Now, some solutions are real and some may be complex. And that's where we move past the Algebra 1 stuff into genuine, true Algebra 2 material, where you're looking at polynomial equations and you've got to deal with the real solutions and the complex solutions as well, if the complex solutions exist. I'm shaking my head because I recorded 2.5 minutes on this particular slide and then accidentally jumped. I hate PowerPoint. Okay, what do I need to be able to do? That's where most of you just home in on really fast, like, okay, Miss Taylor, what are you going to expect from me? What's the skill? What's the concept? What's the thing? So if the polynomial is linear, I want you to solve it as you normally would. We're not doing anything fancy schmancy because a line is a pretty simple polynomial. So you might be thinking to yourself, well, what do you mean? Is it like a line is a polynomial? Why, yes, and a linear equation is technically a polynomial equation. Here's the highest exponent. It's a 1. We don't usually write the 1 because it's redundant, like x to the first power is just x, so we wouldn't bother doing that. But basically a linear equation is a polynomial equation of degree 1, which means we're looking for 1 solution. And so this is where you start off in pre-algebra, algebra 1, in your learning how to solve equations. So we'd go ahead and we would distribute the 2, That would give us 2x minus 6, and then we'll bring down the 4x, bring down the equal sign, bring down the 6. We have a couple of like terms there. I have 4x plus 6x, and 4x plus 6x is 6x. Bring down the minus 6, bring down the equal sign, bring down the 6. Now we have what's called a two-step linear equation. So I'll just add the 6 to both sides. I get 6x is equal to 12. And then I divide both sides by 6, and I get x is equal to 2. So it was a polynomial equation of degree 1, and I was expecting one solution, and I got one solution. Yay, everything is good. Now, just to reinforce some of these key ideas, because this is a fairly short lesson, and I feel like I can and I probably should. If I go and take that 2, and I plug that 2 back in over here in that equation, okay? I have 2, and then this would be 2 minus 3 plus 4 times 2 equals 6. Starting order of operations, 2 minus 3 is -1. And you can kind of mess with your order of operations a little bit there. Parentheses, exponents, I don't have any exponents. Multiplication, division, so I've got from left to right, so I have 2 times -1 is -2, and 4 times 2 is 8. And then adding and subtracting, -2 plus 8 is 6. And wow, check it out. 6 equals 6, which is true. And again, that's what we're looking for. That's what we're always looking for when we're solving our equations, like any kind of equation. So I just really want to drive that point home, because if you can get that, you can actually take some really good guesses at stuff, like stuff that you haven't even been taught. You can figure out stuff, because that never changes, okay? Now, if the polynomial is quadratic, that is degree 2, then what I want you to do is solve it by either factoring or the quadratic formula, okay? Whichever one of those you prefer. If it's not factorable, then you have to use the quadratic formula. And so I have an example here, x squared plus 2x plus 1 equals 0. So remember, with your quadratics, you do need to set them equal to 0 first. So if I had that like 1 on the other side or 2x on the other side, if it was kind of a little jumbled up, we'd want to get it into this form first. And then setting up my factoring, I've got x squared, I have a 1, and I'm looking for two numbers that multiply to give me 1 and add up to give me 2. Well, that would be 1 and 1, and of course those are the x's. X squared only factors one way, and this is a 1 and this is a 1, and 1 times 1 is 1, and everybody's happy. So we have x plus 1 times x plus 1. And the zero product property stating if you have two things multiplied together and the product is 0, then one of these has to be a 0. And we'd subtract the 1 from both sides, and we end up with x is equal to -1. Now, I do want you to notice this. This is going to come up in like several more slides, okay? I get x is equal to -1, and I get it twice. Okay, now there's only one x is equal to -1. If you look at a number line, and I said to you, like, here, point to x is equal to -1, there's only one location on that number line. You can't point to the -1 in multiple places. There's only one spot on the number line where x is equal to -1. And so what we call this is something called multiplicity. It's when one solution turns up more than one time, and it happens when you see the same factor, x plus 1, is put into that polynomial more than once, okay? And that's gonna mess up a couple of our things. Not like super bad, but like it's just something to keep in the back of your head for now, okay? All right, so now I gotta navigate through the next slide, even though, yeah, I gotta navigate through the next slide here. Okay, so if the polynomial is degree 3 or higher, so lines, linear, and quadratic, we spend so much time studying those. If that's what your polynomial is, and quite frankly, most of the time in most of your math, like you're going to be dealing with a line or a quadratic, If you're in a unit like this that's on polynomials, then you're more likely to see the polynomials that are degree 3 or higher. But once you clear this unit in Algebra 2 or college algebra, whatever class you might be taking, you're probably going to see quadratics, okay? Once in a while, a degree 3, stuff higher than a degree 3, like rarely. So if it's degree 3 or higher, this is what I want you to do. I want you to graph it to locate the real solutions. There are things that you can do to figure them out by hand, because obviously we haven't always had graphing calculators where we could just graph them and look for the solutions. So there are strategies that can be used to find them, find all the solutions, but they're very long and they're very involved. Now, once you graph it and you're able to locate the real solutions, use polynomial division to find other solutions. So that's similar to what we did a couple lessons ago, like maybe 4 lessons ago, when we were doing the sum and difference of cubes. We graphed it to find the linear root, and then we used polynomial division to find the other part. And that's still a strategy that you can use now. So if you can find a real solution from the graph, you can turn it around to use polynomial division, or you can try to navigate a multiple choice question using what you already know. Okay, so you can kind of look at what you know about, I have this many real ones, I have this many complex ones, I know the real ones because here they are on the graph, and then like look at your answer choices. So if it's a multiple choice thing that you're dealing with, you got that as an option. If you're dealing with something that's open response, that's going to require a little bit more work from you, and you can't just pick an answer, then you're going to have to use the polynomial division. Now, note, it is worth trying some other things. So it might be worth it to try factoring by grouping. If you see it and you're like, like I think I could factor that, go for it. Like a lot of times it's going to be factorable. So if you tried this one, oh, I don't really like the purple. Let's change that up. There we go. I like that better. So we have x to the third, 3x squared. I showed my mom yesterday factoring by grouping using an area model, and because she's done it the traditional layout her whole life, and she said, oh my word, that's easy. She's like, this like almost makes it a non-problem to do it this way. All right, so once we set up the area model, remember we're looking for a GCF. So I'm going to look right here and say, what's the GCF between x to the third and negative 4x? Well, that would be an x. And then we can use our multiplication to get it the rest of the way, which is the part my mom really loved, because she's used to doing like the repeated factoring over and over again. And with the area model, you really only have to do the GCF factoring one time. Once you have it that one time, you can use your multiplication to get the rest. So x times what gives me x to the third? That would be x squared. X squared times what gives me 3x squared? That's 3. And then x times what gives me negative 4x? That's negative 4. And then you can use this box down here to kind of check it. 3 times negative 4 is negative 12. And so this factors into x plus 3, x squared minus 4. And of course, we have the equals 0, okay? But I can factor x squared minus 4 further, and that would give me x plus 2 and x minus 2. And then we can use the zero product property. So if I have, in this case, 3 things multiplied together and the product is 0, then one of those has to be 0. And that's why you want to know the zero product property. You don't just want to be memorizing shortcuts, because the zero product property works for more than 2 things. Subtracting 3. So one of your solutions is x equals negative 3. You can subtract the 2. One of your solutions is negative 2. And then we could add 2. And one of our solutions is x equals 2. And you can tie this into some of the other things. It's degree 3, which means there are 3 solutions, and there they are. So you could also graph this. So if you've got like time to burn, okay, and you want to pause the video and go over to Desmos and graph that, x to the third plus 3x squared minus 4x minus 12, and just so you could see them, you can like see what it looks like. you're more than welcome to do that. So there are some strategies you can use. And again, the strategies do get progressively more and more complex. Like they can involve stuff like substituting polynomials with other polynomials. It can get a little bit much. All right, I have to stop the video again. Lucky me. If I can avoid clicking like ahead the wrong way, I don't have to keep stopping the video. All right, so this is an example of what's called a quartic polynomial. So just in case you're wondering, where is that coming from? Quartic, oh, what? Quartic is just another word for degree 4. Okay, so the highest polynomial is 4. If the highest polynomial is 5, it's called a quintic, and I almost never use those words. So the ones you need to know are linear, quadratic, and cubic. Okay, so what you can do is go ahead and graph it, and then the solutions are the same as the roots. Now, we did this a little bit before, where if you think of like the 0 as being the y, then what you're looking for over here are the places where the y is 0. You're looking for the x coordinate. And so the solutions to this would be x is equal to -7, x is equal to -3, x is equal to 3, and x is equal to -1. And that is, I mean, most of us, like most of your math teachers and stuff, if I were asked to solve that quartic polynomial on my own, like somebody just said, here, Ms. Taylor, solve this, the first thing I would do is graph it. And I'd see if I could get the solutions that way. And then if I couldn't get the solutions that way, then I might try some other things. Okay, I might try to do some factoring by grouping. What I would probably do here is I would generate a list of possible linear factors. There's a theorem for that. And then I would do progressive polynomial division, okay, to get it. Because what you can do is you could just take, say, the 3 and then divide your polynomial by x minus 3, and you get a smaller polynomial, and then you just keep repeating the process. It's so much fun. All right, now just to reinforce this, and I know I'm probably beating a dead horse here, but I'm going to pick just the x equals 3. Okay, I'm just going to pick that one. Well, no, I'm going to pick the x equals -1. Okay, if I take x equals -1 and I plug it into the equation, okay, and again, I am aware that I am probably just going way overboard with this, okay, but it really is so important. -1 to the 4th, that's -1 times -1 times -1 times -1, which is a positive 1. 8 times -1 to the 3rd. Now the 8 is not being raised to the 3rd, only the -1 is. So you have -1 times -1 times -1, which is -1. 8 times -1 is -8. In the next one, you've got 2 times -1 squared. Again, the 2 is not being squared, only the -1. So -1 times -1 is +1, and 2 times 1 is 2. A -72 times a -1 is +72, or you could think of it as 72 times -1 is -72, and minus -72 is adding 72, minus 63. And you could grab a calculator to do this, but you probably don't care that much. But it does end up being 0 equals 0, which again is that definition of what it means to find a solution. And if you're just like skeptical, you're like, Ms. Taylor, I'm not sure. Take the 3, dump it into Desmos, do like 3 to the 4th power plus 8 times 3 to the 3rd power minus 2 times 3 squared minus 72 times 3 minus 63. And I promise you it'll come out to 0, okay? Because that's how the graph and the equations, like they're all related. So that's an example of a quartic polynomial. And what's good about this one is because it is a quartic, it's degree 4, you know you're looking for 4 solutions, and so if you can see all 4 of them, then you know you've got all of them, okay? So the graph showed you all of them. In this case, all 4 were real solutions, so you could see all 4 of them on the number line. So here's a multiple choice example, and this gets into how you can use what you know about the roots and the solutions. A multiple choice question is just a different beast, okay? It's just a different kind of question, and it's worse in the sense that it's all or nothing. So you're either going to choose the right answer choice and get all the credit, or you're going to choose the wrong one and you're going to get none of the credit, even if a lot of like your pieces and your knowledge are okay. So here's kind of what this looks like. So let's say you were asked to solve x to the third plus 27 equals 0. So you hop on over to Desmos and you graph x to the third plus 27. And then right off, you can see one of the solutions, and that one solution is x equals negative 3. Okay. Now, what I would do at this point is I'd go to my answer choices, and I'm going to look for x equals negative 3. Now, all of these answer choices have an x equals negative 3, but if I had an answer choice that did not have an x equals negative 3, I am not picking that answer choice, and you can eliminate that one. Okay, now here's how you reason your way through it without doing the rest of it. Okay, this is degree 3, which means there are 3 solutions. One of them is real because I can see it, which means 2 of them have to be complex. Okay, so right off the bat, I can eliminate answer choice A. There's only one solution there. Okay, only one solution that's there. So one of them is real, 2 of them have to be complex. It ain't that one. Looking down at now, answer choice B looks pretty promising. If you're like, but I only see 2 solutions there, look right there at the plus or minus. There's actually 2 solutions put in there. One of them is a plus, and then the other solution is the minus. It's just messy looking. Okay, so we've got one real solution and 2 complex solutions. I like B as a candidate, but I do need to make sure that I don't have another candidate that I should be considering. If you look at answer choice C, I have 2 real and 1 complex, but remember that complex solutions always come in pairs. You are never going to pick one that has 1 complex or 1 imaginary answer, or 3 or 5. So we're not picking that one. Okay, now this last one is kind of tricky, like negative 3 with a multiplicity of 3. That would mean that it counts 3 times, okay? That is a rough one, okay? So like it's legitimately like a rough one, because it would say, okay, you check off like the 3 solutions. Now we were thinking 1 real and 2 complex, but what if you had that 1 real one and it just came up multiple times? Okay. This, like, I can show you how, like, if it were from, I'm just trying to think of like the best way to explain this. Here's what you can do. Okay. We've done this. You have the x equals negative 3, and you know that that comes from a factor of x plus 3. Okay. So using what you know of the sum and difference of cubes, I did not do that right. There we go. Okay, we've got x plus 3. You've got x to the third. I'm going to go through this fairly quickly here. You've got, this will be x squared. This becomes 3x squared, but there is no squared term, so this has to be negative 3x squared. This would then have to be negative 3x. This makes this negative 9x, which means this has to be positive 9x, which makes this 9, which makes this 27. And the factors then would be x plus 3 and x squared minus 3x plus 9. The only way that this could be an answer choice is if you had x plus 3, and then another x plus 3. And that's not what we have. So it can't be that one. So it has to be answer choice B. All right. There is one catch, and this is what I was just talking about. I should probably have switched the order of these signs. Sometimes a solution can count more than once. For example, in the quadratic equation is x plus 1, which we looked at earlier in this lesson. It will have a solution of x equals -1, and that will appear twice. And so in the answer choices, it might just say like answer choice A, x equals -1. And you might be tempted to say, oh, I can't have that because it's a quadratic, it's supposed to have 2. I said at times this may make it harder to navigate a multiple choice test, but it should not stop you from eliminating some of the answer choices. And I can go back and we can address like some of these things, what it looks like on the graph and how you can know if you're dealing with duplicate answer choices. However, we still can't cover all of it. Like if it shows up an even number of times, you're going to have like a bounce off the x-axis. But if it shows up an odd number of times, it's still going to cross the x-axis. So there's just so many different kinds of things that can happen. And like I said at the beginning of this lesson, we're just trying to focus on like the main things and the key ideas that will get you to where you need to go. All right. So last slide is a practice. So pause the video right here, okay, and see what you can do. See if there's something you can eliminate before you even think about anything else, okay? And then unpause the video when you are ready to like actually go through and see how would I get through this problem. All right, hopefully you did pause this. Now, there is an answer choice that you can eliminate right at the outset because it violates all the rules of everything, okay? And that is answer choice B. You will never, ever, ever have it, like a situation where you have one answer choice with an I in it. Okay, nope and nope and nope. Okay, so you cannot have, like in this case, it's degree 3. So you're looking for 3 solutions. It is not a possible thing for it to have 2 real solutions and 1 complex solution. Okay, that is not one of the things. So okay, so don't pick answer choice B. If you did pick answer choice B, make sure you make that correction now and also write down why we're not doing answer choice B. Okay, now beyond that, I have answer choice A, which is 2 and -2. And I'm leaning against that one because I'm supposed to have 3 answer choices, but it's possible that one of those shows up more than once. Same with like C, I don't know. If C, we should be able to see it on the graph. And then D has 1 real and 2 imaginary. I can't eliminate any of the rest of these without doing some work, okay? So one of your options, which might be what you did, was to try and graph it. Okay, and when I look at the graph, I can see 2 and -2 as answers. Okay, so I have x equals -2, and I can also see the x is equal to 2. So A could still be it. It's not answer choice C. It's just not that, because if it were, this graph would cross at 4 and -4, and it doesn't. Okay, and I can eliminate answer choice D because I see x equals -2, but I don't see x equals +2. Like these 2 things over here on the right, I know 100% certain that those have to be in my answer choice selections. So D does not have the answer choice of x is equal to 2. Therefore, it has to be that A with one of them counting more than once. Hint, it's the -2. Okay, just actually counts more than once. Now B has the 2 and the -2, but I can't have that Lone Ranger 2I. So this is a great problem where you do have that duplicate 0 in there, and you may or may not know how to navigate like why is it duplicate, like, but you can leverage what you know. You guys are not powerless with this. Now I want to look at another strategy for this, just so you can see like other ways to tackle it. So the other option is to try some factoring by grouping. Okay. And so we've got like the x to the third, 2x squared, negative 4x, and negative 8. So some of you might have decided to do this. I have a GCF of 4. I have the x squared. This is a minus 4. This is a plus 2. And so this actually factors into x plus 2 and x squared minus 4. And then we know that x squared minus 4 is that difference of squares. And as soon as you see that, so it's going to factor into the conjugates. Okay. And then right here, you can see, yep, I have that duplicate factor. So that's going to give me the x is negative 2, but it counts twice. And here's your x equals 2. And so you can get at the answer that way as well. Not one way is better than the other. It really depends on your preference and what your personal skill set is. So anyway, this should set you up for your homework. I have not, at the time of recording this, written any homework, but it'll probably be a lot of multiple choicey kinds of things, just to get pulling like the right pieces of information from there. As always, you guys know how to reach out to me if you have questions.